This is G484 Homework Booklet Question 18. Starting with a definition, but it might not seem obvious as that just at first, so let's look at the wording of the question. It says, state two conditions concerning the acceleration of an oscillating object that must apply for simple harmonic motion. It's the same 2 points that you would make if you were simply asked to define simple harmonic motion. So we have acceleration proportional to the displacement, and we have then a comment on the direction. You can either say it's always directed towards the equilibrium position, or you can say acceleration is always in the opposite direction to the displacement. The next part of the question is looking at the energy involved and changes that happen during simple harmonic motion. You've been given the graph for potential energy against position really, or displacement here. So this is the original graph of different values of potential energy at different positions of the oscillation. You're then asked to complete the graph by adding lines to represent the kinetic energy and the total energy. Now the total energy is probably the easiest one to do. This must always remain the same, following the principle of conservation of energy. So potential energy and kinetic energy will always add up to the same value. Maximum kinetic energy is here at zero displacement, corresponding to the minimum potential energy value. So these graphs here really almost look like a mirror image about that central line. In terms of the accuracy of your drawing of the lines, the mark scheme asks the examiner to check 3 points. This point here corresponding to minus 0.04 meters, the same in the positive side, and this point here. So I would admit that in my diagram these two are not perfect. The two values should exactly add up to the total there. So they're allowing a little bit of leeway in terms of the skill of drawing the curve. We now move on to some mathematical aspects of the situation, and first of all you're asked for the amplitude of the oscillations. This is a very straightforward, just reading off from the graph this value here of 0.04. Now you need to interpret things a little bit more, but still fairly straightforward. You're asked for the maximum speed of the oscillator. You need to read the maximum kinetic energy from the graph as 18 millijoules. From that, you need to be careful handling your units, put your times 10 to the minus 3 in, and then you need to solve by relating that to the equation 1/2 mv squared. So just follow through the maths carefully and you should get an answer of 0.55. Now the next bit asks for the frequency of the oscillations. You've just worked out the maximum speed, so think about how that might link to the frequency. Often one part of a question follows on from the previous, and so you need to use this equation here. Vmax equals 2 pi f times a. So just rearranging and substitution leading to an answer of 2.2 Hertz. Finally, you reach a descriptive part of the question. Now it's worth looking at the wording of this question very carefully to help you construct an answer that will match the requirements of the mark scheme. So resonance can either be useful or a problem. you have to describe one application or one example where it's useful and one where it's a problem. So you've got a first keyword of describe. Secondly, it says for each example, identify what is oscillating and what is causing the oscillations. So you'll see here on the answers that I've constructed them sort of following that style of the question. First, identifying a situation or a context, that's my example. Then identifying what drives the oscillation, and finally what is being driven and what will experience resonance. I'll leave you to read the different examples yourself. I think it's well worth picking one or two from each list and deciding which ones you would find most easy to learn and remember and reproduce in the future. It's worth noting that this one here, the MRI, you will learn more about in G485, so it will make more sense to you in the future. So just read the examples, pick which ones suit you best, and try and put them to memory.